All right, your favorite kitty cat's here to teach you today about chemical bonds. And then we're going to get into naming. What would you name this cat? We have to decide. So we have to look, there's two types of chemical bonds. And I'm going to put this in quotes. Because I mentioned ionic is actually an attraction. Is that electrostatic attraction. Remember that big word we talked about in the last video? And I'm going to tell you all something. The students who are successful in the past treated this as if they were actually in school. Oh, wait, you are in school, because that's how I'm treating it. Not that it's a Google fest. You heard me go off on this before. And so they wanted to understand this information because we keep building on it, not just this class, but in other classes. Electrostatic means positive and negatives attract. So if we have a positive, it's attracted to a negative. It's attracted with dots. All right. Cations are positive. Anions are negative. So they're attracted. And cations, who remembers? I can call on somebody. I'm calling Katie, because her name spells cat. And she would say metals. I know that. Metals. Because they lose electrons. And anions gain electrons. And they are formed by nonmetals. We're going to expand on this looking at chemical nomenclature today. We're going to come back to ions. We're going to talk about covalent ones. Covalent ones share electrons. So ionic, there's a transfer of electrons. Something gains, something loses. But in all honesty, they gained and lost electrons a long time ago. And they now find a new partner. These are the ones that are just attracted. This is a true bond. This is like your shoulder is attached to your body. This is not like, oh, somebody's cooking in the kitchen, potato curry. My arm can't leave me because this kitty cat is rooted to the ground. We need a chainsaw to cut it off, and that would be pretty gory to do on this video. It is Halloween month, though. So a covalent bond requires a chemical reaction. That's where we're going in about a month from now. For us to break that bond. This is just an attraction. It just requires us to put it in water. And actually the water will pull it apart. And they're still ions. They're just now meandering, because that's what the word ion means. Io, she had an affair with Zeus. And then Zeus's god wife, whoever is that, anyway, she got mad and she put a curse on Io, and Io is still here forever and ever roaming the planet. She can never die. But none of us die, do we? That gets into another class, which is really this class because we do quantum mechanics. All right. Covalent shares electrons. These are going to be two or more nonmetals. This is the most important part of the video just happened. You can stop now. You're going to know ionic. You see a metal and a nonmetal. We always show positive before negative. So when you see from the two different sides of the periodic table in a compound, you're dealing with ionic. And when it's all over here in this corner, and why that's important is we're carbon-based. So organic chemistry is the study of organic molecules. So it's pretty much all covalent. And biochemistry, which I am. Ionic is our minerals, the rocks out there. And so in geology, you do some really cool stuff. The other thing we're going to be doing here, which is cool, makes it really simple for me, is I'm a binary cat. Which means there's always only two parts. Like we have two eyes. And so that's one of the beautiful things about being on planet Earth is everything is good or bad, positive or negative. We never get into that unity consciousness. Or do we? All right. So there's going to be two parts. In the real world, there's actually many, many parts. But in Ionic, the positive has to equal the negative. They cancel out. In Covalent, they have to share. It's all about becoming like a noble gas. So, you know these. CO2. The carbon and oxygen, this is what we get to next after we go through naming, is we're going to see how they share. For right now, you just have to name it. So when you see two or more nonmetals, this is where you use counting prefixes, is what I call them. And I wrote your lab, so that's what they're called in your lab. And on Google, they're going to call them something really fancy. And the tutoring center is going to call them something really fancy. And they'll all give you all the answers you need. But you guys all know what CO2 is. Carbon dioxide. Di is in front of the oxygen to tell me there's two. When we have one oxygen, it's called carbon monoxide, and then we don't show the two. Let's do another one. What if you saw N2O5? I have no idea. What do I do with that? Well, we just name it. It's covalent. I know it's covalent because nitrogen and oxygen, oh, they're on that. They're both nonmetals. It's a really important lesson from the previous homework sets. So you tell me. When there is more than one, you tell me. I'll tell you the truth, the mono, I've only ever seen mono used with oxygen and not with anything else. So I avoid it. It's never used with the first element if there's only one. But if there's more than one, you do tell me there's two nitrogens. First element, you just give it its name. Second element, because we're only going to deal with two elements, binary, you end with IDE. So you take a syllable and you add IDE. It's not a perfect rule, but the IDE, it works. So oxygen becomes oxide. Oh, teacher just keeps making mistakes. I like chalk better. Pent oxide. So on your lab, it gives you all this information condensed into like 2 pages, maybe 3 pages, and then a story. All right. The story, you know what? The students have found the stories make no sense until they do it. And then they go back and read the story and they're like, wow, the story gave me a whole bunch of answers. If you have 2 vowels in a row, some people will write pentaoxide and some people drop the A. You're supposed to drop the A. I really don't care. All right, that's covalent in a nutshell. Now, and make a little note. Oh, we'll come back to that. Now we're going to focus on ionic, probably for a half hour. And then we have to talk about acids. All right. We already did this, so I'm just going to review. So cats are positive, anions are negative. So we have fixed for the cations, meaning a fixed charge, or they can have a variable charge. Now writing this down, there's this weird thing that's happened. When you write, it connects to your brain. When you're like watching videos, slideshows. Oh wait, that's all we do. All right, variable charge. The fixed charged are the 1As, alkali metals, +1. The 2As, +2. Aluminum. Aluminum is too teeny tiny to be any other charge. It does not have d electrons. It's once it has the d electron block that the variable stuff happens. So any metal that has d electrons remember, that's why we did all that quantum stuff first. So aluminum's before it gets d, so it's too small. So all these guys in the middle, transition elements, and then after. And these are the ones that get a Roman numeral. We're going to do practice, but Some of you know how to do it already. And then if you know how to do it, it's really good to watch this video and catch all the little pieces you missed. Now, there is a little wee bit exception in here. I'm going to mention it before I forget. And they are, some people call it like this, the glorious staircase. I don't even know what it's called. It turns out this is totally bogus, but everybody keeps teaching it, and your teacher had a mental breakdown between the two videos because I have no control. And when we're in the classroom, I can control this staircase, but I have no control. And the tutors in Google love the staircase. And so silver, 99% of the time, silver is a +1. And so they don't give it a Roman numeral. However, if you actually go into the big book and read the rules, it gets a Roman numeral. So you're going to see sometimes it has a Roman numeral, but sometimes people leave it off. And it's okay. Zinc and cadmium, they like to be a +2. A periodic table that was on the notes, the ion notes, they had, it showed they were in the 2B, and that's because they used to be like that. And gallium likes to be a +3. They're like in a little staircase. Wahaptians, in all honesty, it's kind of like that weird one sig fig rule where it's taught so wrong that everyone does it that way. These are taught as if they're fixed, but they're actually variable. It's just that they're really never found as other charges unless you dig deep into like Chernobyl soil where the earth changed, and then you suddenly find them as other charges. Oh, but wait, we're about to do interplanetary travel. What if we find silver as another charge? The rules will change. So you can just make these no Roman numeral. These always get a Roman numeral. And these, I honestly don't care. If you show a Roman numeral, I won't mark it wrong, but it's only these. And it's because a bunch of you are going to go to Tutor or Google, and they're going to give you all different answers. So I'm giving up. All right. Anions. Comments with them. Always fixed. So somebody said, there's no always in science. And you're right. We just haven't figured out other ones yet. There are two types, and they are called the monos and the polys. I'm going to do the polys in about 10 minutes. The monos are from the periodic table. Cl is a -1. O is a -2. These end with IDE. I'm going to get to the polys. Don't worry. We're going to do a little bit of practice. And then we'll add the polys. And then we'll do the acids. If my cat Rocky wasn't sleeping, I'd have you all come meet him. He's black and white, though. That's why I'm wearing black and white. I do have a tail. All right. Teacher has to think. Let's just use the periodic table to think better. I'm going to give you the names. You're going to write the compounds. Write the ions first. So take each one of those, write your compounds. Well, I think through what ones we're going to go from the compound symbols. You're writing the symbols to the name. And then you can pause me and write these down. Because you don't want to write them down because I'm doing random order. That should be enough. All right. So pause me. Write them all down. Try them. Try something. Nobody's going to know because none of us know each other. I'm going to go through it now. Did you pause me? Are you back? You're supposed to pause me. Did you get the joke? I should have gone and found some pause. All right. Let's write ions. This 2. Tin has a +2. Sulfide means sulfur. So this Roman numeral tells you always for the metal. It always goes with the metal. So tin has a +2. And I'm going to guess that you can't see red. So I'm going to switch to blue. Rocky would not be happy with me, I bet. And then sulfur, from periodic table, predicting charges. If you're having trouble predicting charges, come in and say that as a clear question. Don't fill out the whole lab wrong. Don't just Google answers. Get this, understand it, and you'll do phenomenal. All right. Let's write our ions and then put them together. So chromium, this is 5 + 1. So the ones after the 5, which is 6. Oxide is oxygen. Put a line here. Scandium, Sc. Pretty sure it's named for Scandinavia, but +3. Chloride, Cl with a -1. Scandium is such an overlooked. It's right next to titanium, but titanium gets all the glory because it's an even number. All right, even numbers are more popular. The rub-a-dub-dub, rubidium. I love the rub-a-dub-dub. So thank you, Tiffany. I didn't give you a number. Oh my gosh, do you panic? Do you Google? That's what you do when you panic. You turn to Google. No, you look at your periodic table. That's always right there. And you go, oh, it must be in the first 2 columns. You go, rub-a-dub-dub. Rub-a-dub-dub is not 3 men in a tub. Rub-a-dub-dub was just an electron got kicked out of the tub. We could write a whole new nursery rhyme. Somebody write me a nursery rhyme about, like, an element. Like rub-a-dub-dub, an extra electron in the tub. And what do you think they did? They threw it overboard. So rubidium, rub-a-dub-dub, was like krypton now. That was kryptonite. Okay, that's fine. Sorry, teacher's diverging. There you go. I'm hoping somebody, like a random person's going to email me a random, like, little fairy tale, like 5-line about one of the elements. Eric can make a better rub-a-dub-dub story than me. All right, that was the ions. You're going to write the ions, and then we're going to put it together. All right, here we go. If they're the same charge, just put it together. SNS. Capitalizing matters when you write formulas. No charges in the final answer. All right, this one. Oh, what if you're one of those swappers? What's wrong with this? You know, I can make up names because none of you know anybody in the class. Albert Schweitzer is going to be in my class. You probably all thought it was Albert Einstein, but I'm going to fantasize that Albert Schweitzer is in my class. And if you don't know who he is, you should Google who he is, because Nobel laureate. Pretty awesome guy. All right. Next one. Who should I call on now? Nels. Niels Bohr is in my class too. Other Nobel laureate. I need 3 chlorines. You got it. He is such a smart guy. All right, Maria. Maria Curie is going to be in my class. Madame Maria. Which one needs the 3 this time? Rub-a-dub-dub. 3 men in a tub. Yes, 3 rub-a-dub-dubs in the tub. And there we go. All right. That's our answers. I don't know if any of you have questions, but Albert, Nels, and Maria, they didn't have any questions. All right. You know what? I can have the apostles in my class. Peter, what do you do? Ni. Does it get a Roman numeral? All right. Nickel, he knows, because he is an apostle. It's EL. Roman numeral, Cl is going to be chloride. Oh, by the way, yeah, Peter just reminded me. Hello, teacher dear, you forgot, kitty cat, you forgot to write the ions. I'll write the ions over here. Because you can all see through me, right? Because you can't see me. This must mean that nickel's a 2 and the Cl, because I know that because the chlorine's a -1. And there's 2 chlorines. Now, you don't have to write the chlorine out twice. I just did it because somebody always asks me a question. There's 2 -1s, so the nickel must be a 2. And Apostle Peter is telling me, yes, yes, it goes there. Nickel, 2 chloride. All right. I'm calling Matthew because I just read his book. Absolutely love it, Matthew. What's special about this one? Your teacher is trying to trick you. He's got it. No Roman numeral because lithium is an alkali metal. All right, when you write the names. Yes, Matthew. Now I'm remembering, we're supposed to show our ions. You can do the names and then go back and fill in your ions. But writing the ions is a good practice. I don't care if you capitalize here, but when you write your formulas with the chemical, you have to. All right. Who are we going to call it? Well, after Matthew comes Mark, so copper. He wants me to name it cuprous, so he's kind of showing off here. Sulfur becomes sulfide. He's also wanting me to write it with pH. Mark's giving me a hard time here. All right. Let's write our ions. Thank you, Mark. So, this is, your teacher's pausing because I can hear all of you out there saying, it's a 4. It's not a 4. It's not a 2. It's a 1. Each copper has to be a 1 charge. There's 2 coppers. Each of them is a 1 to give us, to balance the -2. This is the hardest one for a vast majority of the students. When the cation, when you have more cation than anion, because it doesn't happen much. But if you go back to the periodic table that was on the page, the ion page, where I taught about the octet rule, which we have to change the name of the rule, right? But the copper, silver, and gold are called the 1Bs. The only elements that make 1's, charge of 1 plus 1, is the alkali metals, the 1As, and in Mendeleev's original periodic table, copper, silver, and gold were actually part of the table. All right, let's step into poly. The world of polys, and then acids, and then you just got to do it. Don't Google, you just got to do it. You're going to have to find time to come to office hours. You can also go to tutoring if they're probably nicer than I am anyway, because I won't give you answers. All right, so the polys. The key to fill in our little chart here, this is going to be when chlorine and oxygen combine, so you end up with ClO3 with a -1. So you formed a covalent bond, but they still have a charge. If there's a charge, it's ionic. So it actually is going to have both types of bonds. There is a covalent bond between the chlorine and oxygen, but that negative left over. And these are going to be your 8, because they ate up the oxygen. Apparently oxygen tastes really good. And your ites. There are the big 5. Let's just do it with chlor. That's called chlorate. So ClO3 negative is called chlorate. Yeah. And you just combine it the same way. So if I gave you sodium chlorate, so if I wanted you to do sodium chlorate, you would put a sodium, has a +1 with chlorate. So you put the sodium first. Capitalizing is important. The C, the N, the C, and the O are capital. The A is little, the L is little. That's why I write it cursive. The 3 is not that you have 3 chlorates. It's with the oxygen. So this is something your teacher, because she's so awesome. Some of you, if you show a parentheses around your chlorate, that can help. You can always do that. The negative would be on the outside, no negative shown now. Technically, you don't show a parentheses if there's only 1. So my son was in my class last year, Joey, and I let him use parentheses, and they all got it, and they did great. And now he's taking it with another teacher, and he got marked wrong. He lost the whole point out of 1,000. He's only going to have a 99.9%. He did the extra credit, so he's over. All right, do the extra credits. So what if we combine calcium and chlorate? The reason that's interesting is because calcium has a +2 and the ClO3. I'm going to do it with parentheses because that helps a lot of students. It's something I recommend, even though on this one we will keep the parentheses. We need 1 calcium for every 2 chlorates. You keep the parentheses if there's more than 1. You absolutely show it. You do not do this. You do not say, I have a calcium and 2 chlorines and 6 oxygens. Yes, when we do the math, which we will be doing again, we do that. But this is just wrong. That would make your cat very sad. You don't want a sad cat, because sad cats usually become mad cats, and then you're doing extra loads of laundry, because then they pee on your clothes or something. All right. My cat was sad because I went away for like an hour. All right. That's the idea. We're going to do a couple variations on the theme. This is what... In the lab, you have a list. I'm hesitating. That's why your teacher had to break down. The tutoring and online have these big charts of every freaking polyatomic there is. And that's wonderful. And you can use those charts. But you got to use your brain too. I'm going to go through how the chart works. So this is the common one. This is the chart in your lab. And so it's chlorate. I recommend, I'm going to give you a list of 8. I'm simplifying it like we did before when we did this with conversion factors. If you lose 1 oxygen, because these are all about the oxygen, you change the name to ite. So losing 1 oxygen, the charge does not change. So when you change the number of oxygens, the charge does not change. You can lose another oxygen. So from where we started, you started with 3, you now have only 1. The charge stays the same. We don't show the 1. It's still chlorite. Ite means we lost 1. And then hypo means below. It means we're below chlorite. Just like you've heard of nitrates and nitrites, we'll do those in let's do them. So nitrate would be NO3 with a -1. Nitrite, just means it's NO2 with a -1. Having done this for a long time, the students who just learned this, I'm going to give you the big 5, and you just go, oh, I take one away. Or you can go with that big, huge chart, and you're going to be there looking for them all the time, and you're going to be like, you don't give me enough time. You don't give me enough. Sound like kitty cat doing their thing. All right, you can also, you can't take away 3, it turns out, so don't go there. Well, if you did, if you have no oxygens, it's just Cl. And then the ending is IDE, when there's no oxygens. All right, this is just our starting point. We can add an oxygen. You can't add 2. Maybe they can now. There's a point where we get physical constraint. We get into bonding next week more in drawing them. It is chlorate, but you tell me you're above the 8. So normally above means hyper, like hyperactive, like cat. But they don't say hyperchlorate. They say per for the cat. Yes, we get all these cat analogies here. I lost my tail. So perchlorate means we went really high on the number of oxygens. We went above the normal. Now, please notice, it's not the number of oxygens. It's the number different from where we started. And this is why your teacher has 4 stuffed camels. I had to make a choice. Do I dress like a cat or do I dress like a camel? Maybe I'll dress like a camel. You guys, that's another option for you. So I have 4 of these. This is Nick. You're all going to get to know Nick very well. So we're going to talk about Nick. And then we'll talk about acids. So that's the idea. You combine them. We got fixed. We got variable. All right. These are the big 5. You don't really need to know this. This is really funny. There is this little game. I had a student, he's like, you used to have to memorize stuff. You used to have to use your brain cells. Now we're just all going to become Alzheimer's patients sitting there. All right, doing nothing, no thinking, or you can think about them. And he said there's got to be an easier way to do it. And all the girls just made flashcards and memorized them. You don't have to memorize anything, right? And he found this thing online. And it goes, Nick the Camel. Here's Nick. You gotta spell his name right. He's gonna go out. He ate a clam. He only ate 1 clam for supper. Again, you don't have to write all this down, but it's your teacher because this makes her giggle. In Phoenix, not in Portland, but in Phoenix. Because I'll tell you why. These guys, these big 5, they show up. They just keep showing up, and at least recognizing them and not being dependent on charts. It's kind of like the names. Those of you who started to learn, become familiar with the names from periodic table. It really does make things easier. So Nick is NO3. It is nitrate. Carbonate. The next one is chlorate, which we already saw. Supper and phosphate. Oh dear, what did this teacher just do? She gave him 4 oxygens. Yeah, that's the thing with polyatomics. They have different numbers of oxygens. Sulfate and phosphate have 4 oxygens. Their charges are not 1. Yeah, I know how to spell phosphate. Their charges make sense. Phosphate's a -3 like phosphorus. Sulfate is -2 like sulfur. Chlorate's a -1. It's the carbonate and nitrate. Don't make sense. And that's what Nick the Camel told you the charge, because the vowels. Camel had 2. This was -2. Nick has 1 vowel. So the vowels A, E, I, O, U equal the charge. So Phoenix has 3 vowels. Yeah, or you can just memorize it. Portland never worked. Can't eat clams in Portland. And then the consonants, those ones that aren't the A, E, I, O, U. Nick, the consonants were the number of oxygens. So Phoenix, again, worked. Here's the bonus for you. What would you get if he ate the clam for supper in Portland? You get the wrong answer. But that was in the good old days when we had to memorize them. But these are the big 5. We see them a lot. What you should be able to do, again, you can never learn any of this and just hope Google knows it. But if I asked you to do sulfite, you'd say, okay, here is sulfate. You have your big 5 there. And you just go, oh, it's just SO3. Ite just means I take 1 away from what we started with, because Dr. Kitty Cat had 4, now she has 3. The charge stays the same. It's a -2. Because eventually, I'll tell you, I had students this summer and they had done online the whole way through for 2 terms, and they couldn't do anything because they had never tried. I want you guys to try. Or you can be obsessed that you have to have 100% and you're not going to learn anything. Or you can let it go and try and realize that trying is going to help you more than always being perfect. All right, so you put things together just how we said. I erased that beautiful chart I had up there. We're going to talk about acids. There are many more of these. There are hundreds. If you want a page with hundreds, go for it. I stick with the ones that I give in the lab. There are 3 others that I give in the lab. I don't want Nick to do the erasing. He's special. I have to tell you, my class one year bought me a Camel, and they got it sent by Amazon from Phoenix. They looked really hard to find a Camel from Phoenix. He's in my office guarding everything with the gnome. There are 3 other ones that we run into that also are in the lab. OH is hydroxide. And we're going to be doing acids and bases. We run into hydroxide. So it's basically a water molecule. It lost 1 hydrogen. It's -1. Sorry, your teacher can't remember what she's doing. All right, there is this. So carbonate, when it picks up only 1 hydrogen, the charge changes to a -1. It's still an ion. It needs 2 hydrogens. We're going to do acids. This is called bicarbonate. Somebody named it wrong hundreds of years ago. We have forgiven him, but everybody calls it bicarb. A lot of you are into medical fields, you'll say bicarb. This is bicarb. Bi means hydrogen with carbonate. It doesn't mean 2. It's not like a bicycle. Don't think about bicycle day or anything like that. And then there's another one that we'll run into, which is NH4, which has +1. And this one's special because it's positive. It's a cation, so it comes first. And its name is ammonium. So I mentioned this one because you've probably all heard of it. Ammonium is an ion, so it's very soluble. And so the salts that they give people to smell, it turns into a gas, NH3, which has a really strong smell. The smell of ammonia, the smell of cat urine. Yeah. It's like the most disgusting smell to your teacher. Anyway, it's not on the periodic table. AM is mercium, named for this country. Ammonium is NH4. So you just need to know these are the ones, and then if you take away an electron, I'm sorry, if you take away an oxygen, it goes to ite. And really, then you don't have to keep looking at the chart back and forth. Use a brain cell, you don't end up with Alzheimer's. All right, we have to do acids. So I have to make my chart again. Actually, let's talk about acids over here in the area where you can't see as well. Now, speaking of bicycle day, I was at the copier copying something about acids and bases, and a philosophy teacher was there and thought we were talking about LSD. And so it's very interesting when you mention the word acid, what different people comes to their mind. You should not do drugs. Not good things happen. All right. Yeah, your teacher's heart's broken because she's watched a lot of students with a lot of potential, and they're not having a lot of potential anymore. So acids are going to have a hydrogen and a nonmetal. Hydrogen is a nonmetal. It's the only nonmetal that can be positive. It's why they show it with the 1A's. It is not a 1A. Hydrogen with a nonmetal. This is a covalent bond. However, how do we get the positive? When you have hydrogen and chlorine, hydrochloric acid, you need the water. Water, H2O, pulls apart. It cannot do this to anything else that is covalent, but the water pulls it apart. As opposed to ions that actually ionize, they just come apart. The acid needs the water to pull it apart. You don't really need to know that, but they get their own special category. They are covalent. They're a special covalent bond that we're going to talk about, I think, in a week. And they get a special category. The easiest thing to do is to treat them like they're ionic, even though they're not, until they're in the water. And acids are almost always in water. So this is when it's combining with a metal. So if it's an anion, so metal plus the anion, we call it chlorate. Over here, when it becomes an acid, so a hydrogen plus it, its name becomes chloric. So acid names change. Anywhere you had an 8, it becomes an ic. And then anywhere you had an ite, when you make it into an acid, it becomes OUS. A student said acids are icky and they burn us. Somebody systemized it. It just takes practice. Students are always like, I didn't understand acids. That's because it's the end of this long freaking video. When you do it in the lab, everybody does really well with acids. You treat it as an H plus combining with the anion. But you end it with ic or us, and then you say acid. So chloric acid would be HClO3. It's in the lab. What if I asked you to do sulfurous acid? So in the name, they put the word acid at the end. I don't know why they did it, but if you see the word acid, you say, oh no, danger, because acids are special. They burn us because the hydrogen ion is special. So you may have noticed we haven't been doing those numbers over here. But remember those numbers? The mass number? Because they don't matter anymore. It's all about the electrons. They do matter. They determined what element we were with. That's why we started with it. That's the atomic number. So without the plus, hydrogen is 1 proton, 1 electron, and 0 neutrons. Everything else has a neutron. So when you get the plus, it loses the electron. It didn't have a neutron. This is a proton. That is why acids burn. If we were in lab and you got an acid on you, you wouldn't come up to me and say, Dr. Kitty Cat, I got an acid on me. What should I do? You would be at the sink rinsing it with water. If it's high enough concentration. They eat away at metals, so batteries have acid in them. They have to have something that's going to conduct, and so usually it's acid. So most car batteries have acid in it, and you'll start seeing corrosion. Acids were on the periodic table at one point because they're extremely useful. They're used for etching. So making the chips that are in all our computers and all of our electronic devices, they use an acid. All right, so that was a quick reason why acids are so important. Those of you in Chem 104, we will spend a whole week right around Thanksgiving talking about acids and bases. Bases have the hydroxide. All right, so sulfurous acid means we find sulfate, SO4, but we take away an oxygen because the ite was -1 oxygen. And then we add hydrogens. How do I know how many hydrogens? Well, sulfurous, sulfate, sulfurous, sulfur, sulfide, they all have a -2. So I need 2 hydrogens because hydrogen's a +1 and sulfite is a -2. You can put a parentheses if you like. There's our answer. It takes practice. There's something I had to do. Oh, HCl. There's a lot more I can add, but we're going to have to see the questions that come up in the lab. So HCl, if the acid has no oxygen, there are 2 ways they can be named. All right. If there is an oxygen, there's only one way. If there's no oxygen, acid with no oxygen has 2 names. This is great because usually I don't go into this much detail, but since we're online, sure. The one name, you guys all know, hydrochloric acid. By the way, all the acids have historical, like ancient names because they've been around. They're really useful. Hydrochloric, the hydro is the no oxygen. So whenever you see the prefix hydro, you only use it if there's no oxygen. Chloric acid is just HClO3. There's oxygen. So the word oxygen, here's your bonus. Google what the word oxygen means. Tell me what it has to do with acids. All right. The other name is, again, only if there's no oxygens. You just name the 2 parts. No di or mono, nothing like that. Even though it is covalent, just name the 2 parts. It's hydrogen chloride. Now, oh yeah, hopefully you didn't stop the video because there is an important piece I have to add. It depends. This is if it is pure. It is a gas. When they are pure, they're in the gas state. And you and me are 70, 80% water. And we're going to change it from the gas state. And we're going to pull that apart because we are water. And we're going to make it into AQ, which means dissolved in water. So you're going to be screaming. You're not going to even have time. You're going to be that cat doing the cat screaming. Because this is going to burn. Because you have so many freaking protons. Proton was where? Very center. Remember, it had that humongous castle. the biggest castle that could ever exist, like the whole universe. We'd be the planet Earth, and the whole universe would be the rest of the atom, and it's all gone. And now we're just here, this planet, all by itself, with nothing. Planet's freaking out. That's what the proton's doing. It's looking for a home. It just dissolved in your body. So at the chip manufacturers, which is down the street from me, down the street from everyone here, they use hydrogen fluoride, pure gas. Fluoride loves calcium. That's why they're in the special suits instead of the fluoride. That's one of the reasons. There's a couple of reasons. If there is a leak and the fluoride gets contaminated, it eats away their bones, and they end up with a finger with no bone in it. Terrible images. Don't look them up. But they'll close the place down because they have to deal with, contain it. So it's extremely useful. All right. It's different from fluoridating water. We don't fluoridate our water here, again, because of the chip manufacturers, because you cannot purify the fluoride out. There, it's a fluoride ion, and that's a whole nother can of worms to talk about. But I can smell the potato curry, and I love it. So we're going to say bye. Till next time, I hope you have a perfect day. Didn't stop. Okay, I gotta make another cat. What else would be a silly cat thing to say?